The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Benjamin J. Heckendorf. Every week he takes on new projects, shares tips and tricks, and answers your viewer questions on The Ben Heck Show.
Hello and welcome back to The Ben Heck Show. In today's episode, we're taking on a viewer challenge to build a motorized camera dolly. It will move a camera along a linear path with a smooth, consistent motion for a professional look. This could also be used for time-lapse, for instance, to get a panning shot of a sunset. Today, for the first half of the project, we'll build the mechanical dolly itself, and next week, add the motors and electronics to make it move. Let's take a look at our design ideas and get started.
But first, the news.
Today in Ben News, I'd like to show you this new Rgb Laser I acquired. It's a laser assembly that has 3 different colors in it, and they're combined using 45-degree mirrors. And these lasers are really bright. That's why I'm wearing these sunglasses. I'm not trying to look like the Terminator, even if I do. So what we're gonna do in this test here is shoot the laser at this mirror, which you're gonna rotate on this motor, and we should get some different pulses showing us the separation on the ceiling. Eventually I want to build a raster display using this, but this is just the first test, the first example of how the system will work. Pretty cool, huh? Well, eventually I can evolve this into a full frame raster image, so this project will be back. Here's my plan of attack for the camera dolly system. We'll get 2 pieces of conduit, which is the type of metal tubing they use in walls to run electrical wires. And we'll have 2 end blocks, probably made into 2x4s, so that the conduit will slide into. Then we'll make a carriage, which will actually hold the camera. My idea is to actually have a tripod on the carriage. That way you can attach the camera to the tripod and then tape the tripod to the carriage. It will roll via 4 sets of 2 45-degree rollers or washers or bearings. We'll have to see what we can find. And those will hit the conduit at 45 degrees right here in a V shape. That way we can use gravity and weight to hold it on the rails instead of anything else. See, we might as well use gravity to our advantage. I mean, it's free, it's all around us. Then to actually propel it forward, we'll have a eye hook and a rope or string of some kind going to a gear motor and a pulley. And we just want to make this really simple, so the motor will basically just slowly pull it toward itself. And we might have a bit of an incline here, so gravity is always kind of pulling this back a little bit. That way it doesn't jerk or overshoot when the motor pulls it. So in this episode, we're going to build the mechanical frame. In the next episode, we'll build the electronics to drive the gear motor and then test it. Here are the parts I've collected from the hardware store, Menards, Home Depot, etc. to make the dolly. Got a 2x4 here. Of course, 2x4s aren't exactly 2x4 inches, fun fact. Then we have some machine screws here. We'll use those to mount our plastic wheels. I've got enough of these so I can mount 2 of them at all the 4 corners. Screw eyes, basically we'll use these to attach the rope or whatever pulls the dolly along. Then here's the conduit. This is the stuff, you see it in the shop, they use it in shops and whatnot, basically to run electrical. But here we're using it as our guide rail, and it's fairly straight actually. I would have got longer ones, but these were the only ones that would fit in my car. So we're gonna use this 2x4 to make the end pillow blocks that the conduit fits into, so the wheels will roll along it. So we want to use a regular tripod with the legs folded all the way up. So we need to see what that spacing is. Okay, it's about 15 inches on center. So I'd say an 18-inch wide carriage would be a safe bet. So if the carriage is 18 inches wide, that means our pillow block should be the same width. 18 inches. And then the rods inside of that should be a sub measurement. I would say probably 4 in by 4 in. So our rods go here and our piece is that long. So if we have these hanging in space, they might sag a little bit in the middle. So halfway through, we could use this to brace it. Yeah, so we can use that to judge where we should put this. Okay. That would be 1 1/8 inches on center. Now I'm going to use a spade bit to make a hole. Drill a pilot hole. Now in order to help keep it straight, we want the depth to be the same on either side, so I'll make a mark on my spade bit actually so we know how deep it goes. Now I know how deep to drill. I need to get a drill press. X marks the spot. I knew that would happen. Why did I do it? Ugh. Pretty good. I can shim this with some tape.
Get dev kits fast. Element 14, your dev kit HQ.
See, I use power tools. Now I'm doing the same thing for the other side. Although one of them I might have an extra hole in case we want to thread the pull cord through that. Working on the night moves. Sorry, I got that song stuck in my head. Note to self, get a drill press. It's like the worst place for this thing possible. I'm gonna make some end supports just in case. I mean, these will probably set flat, but never hurts to make it more secure. That was shed. Mountains have moved, caught like a wildfire. I'm gonna drill some pilot holes so the wood doesn't crack on end. Oh man, all this woodworking is working up a sweat, so I needed my fan to stay cool so my brain doesn't overheat. She got out of town, subway New York bound. I need more table. All right, have a new work surface. It's not ideal, but it's long enough to fit this. So I'm going to wrap some tape around the ends of these pipes so they fit snugly into our holes. Yeah, there we go. Your chin doubles as a tape holder in case of a water landing. There we go. So I'm not sure if we really need supports under these conduits here. The table's not perfectly flat, so it's not the best indicator. I think what I'd like to do is make the carriage next, so we see how much weight's gonna be applied to this and then decide if we need more supports. So I'm going to make the wheel mounts. So the wheel mounts that will roll on this conduit, they're printing out on the 3D printer right now. In the meantime, I cut the plate for the carriage itself. This will attach to the wheel mounts and slide back and forth on the conduit. The tripod will just sit in these 3 holes just like that. Then you can tape it down or however you wanna adhere it. So if your subject goes over there, that's what happens. So we're waiting on the wheel mounts. Here are the 3D printed brackets for the wheels. For the wheels themselves, I got these nylon roller things from Menards. Menards is like a Midwest version of Lowe's or Home Depot. And these are probably meant for like a dresser drawer or something, but what I'm gonna do is I'm gonna bolt them onto the nubs here and then put these screws in at 45 degrees. And then what'll happen is this thing will ride the conduit like that. I have all 4 wheel mounts printed out. So I've actually got the platform upside down so I can attach the things to it with the rails on top. That way I can see what I'm doing. So I'm gonna make sure first that it's centered on our track, just for balance purposes. 58.5 divided by 2 is 29.25. So I will, if I can do this, make a mark here. All right, that's the center. Okay, at 16, which is 8. Center mark. Gonna put this on center. So we're using the track to align where we bolt down these wheels. So now that we have it centered in that direction, we want to make sure that it's equal on both sides. So the distance to the outer side of the mounts here is 12.5 inches. Total of this is 18, so we take 18 minus 12.5, which is 5.5. Divide that by 2, which is 2.75. So these will be 2.75 inches in on either side, and that will make them centered. All right, now I know where to bolt them in. I could have made marks on the bottom of the board, but I'm showing you how to do things manually. We built it upside down so it would assemble correctly, but of course it actually goes like this. I know something else we should do. Make marks where the tracks are so it's easy to set down. To set this up, we're going to do a weird shot. Cameras filming cameras. Obviously this one's going to be on the motion track. Here we go. It's got some wobble, but we can fix that by putting something under these tubes and adding weight to the platform itself. It's just fun to push around. So in the next episode, we're going to actually do the electronics so we can pull this at a specific rate. And our purpose for this wasn't really to make it a motion camera, but a time-lapse camera. So you film like the sunset or something, or traffic, and you just move this like 1/8 of an inch every minute. So you get a slow time lapse with motion. Today's viewer question comes from Jonas, who asks, I was wondering if there's any issues with desoldering and rewiring HDMI jacks and cabling, such as with the Raspberry Pi. Well, Jonas, with the Raspberry Pi, you're best off leaving that HDMI jack in place. It uses surface mount connections, which would be very hard to rewire by hand. You can, however, hack up an HDMI cable itself, plug it in, and rewire it from there. Be sure you keep track of the twisted pairs inside of the HDMI cable and leave all the shielding ground for every one of them. Even with through-hole HDMI jacks, desoldering it out of the PCB can be difficult, especially if there's an internal ground plane in the circuit board. You can, however, plug a jack into one device and then manually wire the other end to the circuit board pins, not the jack itself, on the device you want it to go to. This can save you space as HDMI jacks aren't terribly small. You can also hack up the shielding around the end of the jack. What's inside is not nearly as big as the plug itself. Thanks for watching. Join us again next week to see the finished project. We'll add the motors and a pulley system and then build a circuit to move the camera at a specific speed. Our plan is to use a still image camera and create a motion time lapse. We'll see you then. Stay tuned at element14.com/TBHS, where you can join the discussion, suggest builds for the show, and even have a chance to win upcoming builds. Remember, you can always email build ideas to benheck@element14.com. Thanks for watching.